I'm more prepared than usual. So it's good. I did the prep and the homework already. So nice. Let's see if I can remember any of it though.
Okay. Just let me know when you get the group quiz of it.
I've got it.
Okay.
Oh, hold on. So before we do this, just so I don't forget, I did get an email back, and it's from the TA, from Adam, and he says that he's updated the group sign-up sheet and removed all the names that are no longer registered with the course. And he says in groups 3, 4, and 11, one of us could go to any of those 3 groups. Depending, they said that the times are different than what like we had originally listed our meeting time for, but we're also not meeting at the same time we had originally. So we could look at those groups if you want to and see if our the times work, or we can just decide to go ahead with our project. I'm okay either way.
Yeah, I don't know. I think it's a lot simpler the way that we're doing it, a lot that I looked at. And so I feel like it would just make it a little bit more complicated.
If ways changed. Okay. All right. Yeah. I'll reply to that effect then. Okay.
Okay.
All right, ready for the group quiz.
Yeah, because I looked at it and what we chose and how we simplified it down to just one bedroom is so simple compared to what a lot of other people are doing. Because there's a whole nother 8 steps if we had done a survey on campus and all that stuff. So.
Okay. Yeah. Okay. So there's information here. It says just to make sure it's 3 decimal. Okay. All right. So for the next 9 questions, we'll review the PTC tasting study with different data. Out of 70 females in the sample, 52 can taste PTC. Out of 59 males in the sample, 42 can taste PTC. Please use the data presented here. There is a table. So let P1 be the proportion of females in the population who can taste PTC, and let P2 be the proportion of males. The research question for the study is given here. Is the proportion of females who can taste PTC different from the proportion of males who can taste PTC? So number 3 says use the data in the table to find P1. Divide the number of females that could taste it, right? Is the proportion of females who taste? Yeah. So the number of females in the yes row divided by the total. Is it the total? Hold on. What is it divided by?
The total. Is it the total or total females?
Total females.
Okay. Yeah. So 52 divided by 70 because it's x over n, right? For P1. Yeah, that makes sense because it's just P1. I got 0.279.
I got 0.743. Did you do 52 divided by 70?
Oh, I did 51 divided by 70.
Oh.
Yeah, I don't know why. Okay, yeah, 0.743.
Okay.
Okay, question 4, use the data in the table to find P2. So that would just be 42 divided by 59.
So 0.712. Okay, which set of hypotheses is appropriate for addressing the research question? Okay, so I'm going to say that that is A.
And how do you know that it's
So
equal?
up here in the information, it says that the research questions, the last sentence of the information section, the research question for the study is given here. Is the proportion of females who can taste PTC different from the proportion of who can taste PTC? So it's equal to or not equal to. And the only other one is this P1 equals P2, and the alternative hypothesis is that P hat 1 equals P hat 2.
Yeah.
So I would think that it's just the first one.
Yeah, that makes sense. Okay. What is the point estimator for a 95% confidence interval?
Okay. I'm gonna fill in that analysis sheet, and then that will probably give us more, hopefully more answers to it.
Yeah. Wait, so this one we just, put into
Because that gives us,
Excel.
yeah, P hat. Okay. Out of 72.
Wait, so you're just putting this into Excel, right? Or how are you doing
Yeah,
this?
into the I'm putting it into the categorical data analysis hat sheet.
Hat sheet?
Yeah, so it's called categorical data analysis _ hat.
Oh, right. But the two proportions in that, right?
Oh, yeah. So I'm just putting like X1 and N1 and X2 and N2. And
okay, yeah.
Then for the confidence interval.
And so X1 is 52.
Yeah, and then N1 is 70, X2 is 42, and N2 is 59.
Okay.
All right. So for P hat 1 of, is that what we're supposed to figure out? Which one? What is the point estimate? Okay, then now I don't know. I'm so confused now, maybe. Okay, because I have 2 point estimates, so maybe this is not how we figure this out. Okay, let me go back to the book.
So the point estimate, that's just a p hat, right?
That's what I thought. So, but on this like sheet, it gives you a P hat for 1 and a P hat for 2.
Right.
And it's only asking for 1, but it doesn't say which one. So I'm thinking that maybe there's a different way that we're supposed to figure this out. Oh, for P1 minus P2. Right? Is that what they want? Because it says information created 95% confidence.
Oh, yeah, maybe p hat 1 minus p hat 2, maybe? I don't know.
P1 minus P2. So we would then have to compute this, I think. Let me go back to the next.
Yeah, that's the only thing I could think of. So it'd be like 0.743 minus 0.712. Does that make sense? Or...
I mean, that sounds like a good guess. I don't know if that's right or not. We can try it because I'm trying to find in the text where it gives anything like this, and I don't.
Yeah, I couldn't find anything either this lesson. Let's see if I go back to, let's see, past lessons. In the past lesson, yeah, I remember it just talked about, I'm looking at it right now, that p hat is just a point estimate of p. So in other words, p hat
Okay.
is the point estimate.
So I'm wondering this
So-
because the question says P1 minus P2, not P hat 1 minus P hat 2. So I'm wondering if we need to take the, like, so if we need to take those proportions first, like, or before they actually, like, before we convert them. I don't know. Like if they want to figure out the average proportion. Does that make sense? Like,
Yeah.
like I'm trying to like subtract 52 and 42, like, and then 70, 59 to come a proportion, but I don't know, 52. Let me just see what that would be if it's a larger number, 10 divided by 11. Oh, see, that just seems weird. I don't know.
Yeah,
You try it your way first, and then we'll see.
well, it says the only thing is it says the point estimate is equal to x over n, which is just p hat. So, but yeah, there being two, I don't know. Guess we just subtract.
Okay. Let's see what we get. Okay.
But I would subtract before the rounded numbers just so we can get accurate as possible.
Okay. So 0.031.
Yeah. Mm-hmm.
Okay, I have a real problem with margin of errors. I realized this like because when I was doing the homework, that's the only one I got wrong, and I really had no idea. Like,
Yeah.
I'm like, I think I'm gonna have to ask for some extra help with that because I don't know how to compute these at all. Let's see. So if we go back to, I know the last lesson had a formula. Let me find my notes just a minute. Sorry.
Yeah, so the margin of error is for what we're on now is the m equals z times square root
Okay.
of p times 1 minus p over n.
Wait, the square root of p times 1 minus p over n, right? Is that what you said?
Yes.
Okay. Which is the standard deviation formula. So let's see here. So let's see. Okay, so I've got the standard, they give us the standard deviation of the confidence interval here on that spreadsheet. And that's this square root of p times 1 minus p over n is the formula for the standard deviation.
Mm-hmm.
So it's just z times the standard deviation. So it should. What? We can try to figure out the long way and see what we get. Just to make sure.
Yeah, my only thing is like I'm not sure what to put in for p in the equation when we have two proportions.
Oh yeah. How does it figure that out?
Let me see. Maybe there's a different equation for this one. I didn't see anything when I was kind of looking through the text, but I can search it. Yeah, there's no new formula. So for margin of error, just the one from last lesson that it was introduced like this.
So this is what Excel does here. So when I'm looking at the standard deviation for the confidence interval formula, it has the square root of C16, which is p hat 1. So the square root of p hat 1 times 1 minus p hat 1 over n1. And then it adds, like, so plus, let's see, plus p hat 2 times 1 minus p hat 2 over the sample size for 2. So like, and then you square root all of that. So I think you the two together to get the confidence interval p hat then, like, or no, how did you figure out the freaking p hat? I still can't figure that out. Yeah, okay, but anyway, that's how you figure out what the standard deviation of the confidence interval is between the two.
Okay, well, so I know for the confidence interval itself, it was just that whole equation for margin of that's your margin of error, but it's p hat plus p hat minus margin of error is your lower bound, and p hat plus margin of error is your upper bound.
But how do we figure out the margin of error?
Yeah, that.
Okay. Let's see. Because what I'm getting for the answer to this one is 0.031, which is what we put for the point estimate. So I think that our point estimate is probably not right, because I actually have a formula for this. And maybe that's not a minus sign up there for create a 95% confidence interval for, maybe it's just P1 to P2.
Yeah, that's the thing. The margin of error. Well, I guess what is P in this whole thing?
Well, we don't know, so we estimate it as P hat.
Oh, that's right. Oh, okay, and then the p hat 1 minus p hat 2 was the 0.301 that we got.
Yeah, but I don't think it. I'm thinking it's not a minus sign anymore.
It's not.
I don't know, because what I got for the margin of error is the same thing. We can keep it and just.
Yeah, maybe we should just keep 0.031 on both, because it sounds like at least one of those is right.
And then just see what happens, and then we'll take it.
Yeah, and then we'll know which one's wrong and where to go from there. I don't know, because otherwise, because I have no idea how to use the equation without knowing P for margin of error. And there's no new equation, so.
Are you looking at this categorical data analysis sheet?
No.
Okay, do you have it?
Yeah, I just opened it up.
Okay, so if you put your cursor into the standard deviation of confidence interval square, so F16, you can look at the formula and see it says it's this, so the standard deviation formula is this square root of P times 1 minus P over N. That's the standard deviation formula. And so put in there for P is, so it's a C16, so it's P hat 1. And then they add, like, so they do the standard deviation formula, like, they add the 2 P hats, like, formulas. So they do, you can see that it says, like, P hat 1, so C16 is P hat 1 times 1 minus C16, so 1 minus P hat 1. So instead of P, they just put the P hat in there.
Oh, wait, yeah, I have that written down too. So it's just the same thing, but P hat times 1 minus P hat over N square root of that.
Yeah.
What the heck? Just a second. Yeah, what, it's 7752? Nothing, I didn't open up any door. No, it shouldn't have been. Sorry about that.
Not a problem. Okay.
Yeah, so I think it's just P hat in the same equation will give us the answer.
Okay, so are we ready? Are you still working on 7, or are you ready to move on to 8?
Let's see, let's go back. Well, so I guess the only question about 7 would be, I mean, if we.
So what I did was, since the margin of error is basically the z-score multiplied by the standard deviation, I just did that. Like, I took from this categorical data analysis _ hat sheet, I took the z-score and multiplied it by the standard deviation of the confidence interval to get that 0.031.
Okay. Okay, yeah, we'll stick with that. That makes sense. Then we can move on. So for question 8.
The lower bound.
Yeah, so that we can just take from the Excel sheet negative 0.123.
Is 0.185. Okay, so with a level of significance of 0.05, what decision do you make? So let's see.
We failed to reject.
Okay. No.
All right. Question 11. Which of the following statements best describes the outcome of this study?
Wait, you said fail to reject?
Yeah, so the P is, you have 0.837, right?
Oh, 0.693. What in the world do I have in here wrong?
Oh, wait, hold on. I was on a completely different, that would do it. I was on the quantitative inference sheet. Okay, I got 0.693, yeah, okay.
So is that the same? I always.
But that's still greater than 0.05.
Oh yeah. Okay. Okay.
So yeah, we failed to reject, but that means that we have insufficient evidence to prove that there's a difference.
Yeah, I would agree.
Let's see, which one is that?
Oh. Insufficient evidence to suggest that the true proportion of females who contain species less than O. There's insufficient.
Oh, I think D.
I agree.
Okay.
Okay, for the next 9 questions, we review the mortality rates and day of admission, heart attacks, study. Okay. So out of 108, okay, 118,519 who had a heart attack during a weekday. 16,713 had died. I'm going to put that in the sheet now. Okay. So what do they want? Okay. So let P1 be the proportion of patients who had heart attack and were admitted on a weekday who died. And let P2 be the proportion of patients who had heart attack and were admitted on a weekend who died. Okay, so the research question is the proportion of patients who have a heart attack and are admitted to the hospital on a weekday who die less than the proportion of patients who have a heart attack and are admitted to the hospital on the weekend who die? So whether the weekday deaths are less than the weekend deaths.
Okay, so P1 is weekday and P2 weekend.
So you're putting P1 as weekday?
Yes.
Okay. Okay. I don't know whether P1 is less than P2. So the conditions for conducting a hypothesis test, are they satisfied? Yes.
Let's see. Sorry, I just finished putting the numbers. What's the confidence level?
What is this?
I don't think it tells us.
What? Oh no, it's asking if the conditions have been met for the hypothesis test.
Yeah, it has.
Yeah.
Okay, 13. So it's less than P2. So D, right? Based off of the question.
Yes.
Okay.
And P1.
Find P hat 1.
P hat 1, yes. 0.141. So you got 0.141.
Yes.
Okay, and for P hat 2, 0.145.
Oh, I haven't done that.
Okay. It gives it to you in the sheet.
Oh, I didn't see that. Wait, where does it give it to you in the sheet?
So under descriptive statistics.
Oh, okay. Yeah, I just saw it. I don't know. I calculated that. Like I didn't know that was in there.
Well, good. Now
Okay.
your calculations are correct, though. Find the z-score.
Okay. So we use the normal probability applet for this.
To find the z-score? It gives it to you in the sheet again.
Oh, wow, okay.
Under
like-
proportion z-test, it's z negative
Oh, yeah.
2, 0.
If the z-score from the last question, which should you shade the left or the right for the p-value?
Less. I would say left. Oh, but it's a negative, so does that make it different?
Well, I think the only thing that makes a difference is the fact that the alternative hypothesis is less than.
Okay.
Yeah, when it's
Yeah,
not equal to, it's like the tails, and so yeah, I think it's that's what matters, and so it's to the left.
Okay, because I was wondering if the negative would change it to the other side for some reason, but okay, good. All right. Okay, so what is the p-value for this test? I'll just make sure Applet gives us the same thing as the sheet. How about that?
0.043.
What's the zeros? -2. I have 0.0217, so 0.022 is what I got.
Well, I just used the p-value given in the
probability split. Oh, in the sheet. So that's what I have too, though. I had the same thing, 0.022 in the. So what do we have to?
Wait, so oh, okay. No, I think I realized I had not equals. Yeah, 0.222 or 0.22. Yeah.
Okay, and I checked the applet when just highlighting the left and then got the same thing. So that's correct.
Yeah. And so what was our significance again?
0.05.
Okay. So alpha is greater, so we reject. No. Which means that
That there's sufficient evidence to conclude that, let's see,
that there is sufficient evidence to conclude that there is less on the weekday.
A heart attack and are admitted to the hospital on weekday who die is less than the proportion of patients who have a heart attack.
So C, right?
Yep.
Yeah. All right, that wasn't so bad. 20 questions kind of sounds a lot, but
I thought it felt like, I mean, it wasn't too bad, but yeah, I was like, so many questions. Okay, let's see.
the margin of error is the thing that, or one of those questions that we know we'll get wrong, but we'll see.
Okay, so the point estimate we got right. So you're right about subtracting that. The margin of error is still wrong. What the crap did we do wrong? See, it's like I think I know it, but then, I mean, I use the freaking formula, and I don't know what I'm getting wrong with the margin of error.
Yeah, so the only thing I can think of with the margin of error is that it has to be, yeah, because I found my other equation that I have written down that just changes. You can do the same thing, but with p hat instead of p. So it's z times square root of p hat 1 minus p hat over n. But when you have 2, I don't know how that, like, is it maybe that what we got in question 6? It's p hat 1 or minus p hat 2, and that's your p hat that you use for that. I guess that would make sense. You see what I'm saying?
Yeah. I don't
So
know.
yeah, I don't know.
Is it worth it to you to go back and do this again for the one question?
For the 1 point, I haven't taken the homework yet, so I'm gonna I'm gonna do that on the homework. I'm not gonna
Okay.
affect the effort here, but
Yeah.
I'll go back on the homework and see if that's right, what I was just talking about. So.
All right, I'm good at the 95. All right, well, thank you, Dylan.
Yeah. So on the project.
I'll reply back to them and let them know that we're just gonna.
Okay, but yeah. So our next thing isn't due until the end of next week, but
We have to collect data, right?
right, yeah. So that's gonna take some time. So just whenever you wanted to start that, if you
Can we
want to do
discuss
that,
that on Wednesday and start it?
yeah, that's fine. That works.
Okay. Okay, so we'll discuss how, like, who's gonna do what and all
Yeah,
that. We can.
figure it out. Figure that all out.
Okay, awesome. Thanks.
Yep. Thanks.
Bye.